Hello everybody. The purpose of Lab 1 was to analyze the motion of an object traveling at a constant velocity. Once motion was captured, I analyzed the data using Newton's second law, otherwise known as the momentum principle, as well as the position and velocity update formulas. Here is my tracker data. I put my positive x-axis to the right of the origin. Because of that, my motion showed up in the fourth quadrant of a standard Euclidean xy plane. If I were to have flipped my axis around, the motion would have been an upward sloping line similar to the line y equals x. Once I ran my tracker simulation, I was able to gather these sets of data to plug into my GlowScript code. I knew that my start time was 0, final time was 0.83 seconds, and I was able to calculate initial position and initial velocity using Newton's second law equations. And I also made note that mass is irrelevant because our Fnet is equal to 0. Therefore, mass is irrelevant in a constant velocity problem. Now that I have points from Tracker, I was able to plug them into the starter code in my GlowScript simulation. I knew the Frisbee's initial position and velocity vectors, as stated here, and I knew also to set Fnet equal to 0. By setting Fnet equal to 0, that makes the mass of the ball and delta t irrelevant. From there, I used the velocity update and position update formulas in a while loop in order to create the motion of my Frisbee moving at a constant velocity. Here is a clip of my program running. As you can see, it models the motion of my Frisbee moving in the left direction and produces a graph that is very similar to that we saw on Tracker. Now that we've collected data from both Tracker and GlowScript, I was able to put it all into an Excel spreadsheet and create this position versus time graph. The blue line on top is our observed motion from Tracker. The orange line on the bottom is our predicted motion from GlowScript. The points at the beginning of the graph line up quite nicely. This is because what we used as our initial velocity and position in our GlowScript code was the true initial position and velocity that we got from Tracker. However, our GlowScript code, because net force was equal to 0, it continued on simulating an object with perfect constant velocity, hence the perfect linear line. Whereas our observed motion, there were some flaws as time went on, whether that be from an unknown force that we don't know, or human error. That's the reason why there's a difference. I'm not sure what it is, only more experiments and time can tell. I will leave you all with a final observation. We know that Fnet was equal to 0. So Fnet is the summation of all the forces, all the pushes and pulls in a system. However, we don't know how many pushes and pulls there are in that system. There could be as many as 2, there could be as little as 2, as many as 20 million thousand. No one really knows. However, we do know that there's at least 2 forces at play here. We know that there's some type of gravity pulling down on the object. And because there's a gravity pulling down, there has to be an equal yet opposite force pulling up on the object. I'm not sure what that's called, so I'll leave you with an F sub question mark. But that's my final observation. We don't know how many pushes and pulls there are, but there has to be something counteracting gravity.